Okay, in this video, we're going to uh, work on, so this is the fourth question or problem in it's a past ACSL contest number 4. It's from the 2019 to 2020 ACSL season. This is for contest number 4 for the elementary division. So the question, okay, so this is graph theory, topics graph theory. So in the undirected graph below, how many cycles are there? Remember that cycles must include at least 3 vertices or nodes, or you think of it as points. Those are the letters in an undirected graph, and is a different cycle, and it is a different cycle if it goes the opposite way. Okay, so let me pick a different color. Orange. Okay, so we can see that there's one here, right? There's one here. So that would be, and that has a length of 3 because there are 3 edges. Okay, so you have to have at least 3 vertices, or at least 3 vertices or 3 nodes. At least 3. Okay, so vertices, nodes in the cycle. So we would be W, X, Y, and then back to W. Okay. And then the other one would be the opposite way. It would be W, Y, X, W. Okay. So that's we have 2 there that are that has at least 3 vertices in it. Okay, we start at W, go to X, then Y, and then back to W. Or we could go the other way. We start at W, we go to Y, go to X, and then back to W. Okay, so that's we have there. So that's one vertex. Okay, so that's we have. Oops. Oh boy. Okay, so that's one vertex. Okay, and then we have use a different color, yellow, and then we have this one, right? So we have this one, the yellow. Oops, the yellow one, right? So we have this one. Okay. So in this one, so we would be it would be X, Y, Z, and then back to X. And then we can go the other way. We have X, Z, Y, and X. Okay, so we have X, Y, Z, X, Y, Z, X, or X, Z, Y, X. Okay, so we have those 2. So we have right now a total of 4. Okay, and so that we have a total of 4. So we have a total of 4 with a length of 3. So we have total of 4 with a length of 3, or 3 edges. 3 edges, 3 vertices, 3 edges. Okay, and then we have another one that has 4 edges. Okay, so there's total of 2. Okay, of length of 4. Okay, so let me see. Okay, let me try to pick a green. Okay, I'm gonna pick green. So we have this one. Okay, so we have this one, right? So we have, so it's so we can say W, X, wx to z, then to y, and then back to w. W to x to z, then z to y, then y to w. And then we can go the other way. W, y, z, x, and then back to w. So we could go w, x, z, y, and back to w, or we could go w, y, z, w, y, w, y, z, x, w. So we could go w to y, y to z, z to x, then x back to w. Okay, so then we could have, and then we would have, so have length of 4, which means there are 4 edges, and also means there are 4 nodes. Okay, so we have a total. So we have a total. Oops, sorry, it's hard to write here. Sorry, using a mouse to write here. So we have a total of 6. So we have a total of 6 cycles. Okay, 6 cycles. So these are paths that start at one node or vertex and then comes back to the same node or vertex. Okay, and we need to keep in mind that the total number of cycles, okay, total number of cycles must be an even number. Okay, so it's not possible. So in an undirected graph, so you can't have an odd number of cycles. You must have an even number of cycles. Okay, so 6 is an even number. So that indicates that that this is the correct answer. If we had an odd number, then something's wrong. Then you've made a mistake. Can't be an odd number. Total number of cycles in an undirected graph has to be an even number. Okay. Okay. So this was problem number 4 in the ACS in contest number 4 for the elementary division. And this is from the ACSL season, from the 2019-2020 ACSL season.